only mode.
All right, well, welcome everybody. My name is Kevin Williams and I'm with ClearEdge 3D, and I'm going to be the host for today's Workflow 4.0 webinar on new automated cloud-to-cloud registration technology, the LineUp Pro to EdgeWise workflow. Now, just a little bit of background. We've been working with Gexcel for a little while now, and we've internally been using this technology and just been really impressed with it. We've used it to register a number of different data sets that we've received from customers with misregistration issues, and it's worked flawlessly for us, and it's very automated, and so it's something that we've enjoyed using, and we thought that it would be a really neat thing to show the rest of our user base and anybody else out on the web. It's some cool technology, so I hope you guys enjoy seeing this presentation today. Just a brief agenda and then we'll get started. So I will introduce our presenters real quickly. We've got Mike Coman with Real2Desk, who's going to be giving two different case studies, an underground parking garage and an industrial plant extension. Then Matteo with Gexcel is going to be doing a LineUp Pro demonstration. And then finally, I'll take a couple of minutes at the end and talk about some of the things that we're working on the EdgeWise side. And then at the end, I hope to have about 10 or 15 minutes to do some Q&A, because I'm sure there's going to be a lot of questions from the audience on this one. So just a real quick overview of the housekeeping rules for the Workflow 4.0 webinars. Everybody in the audience is going to remain muted during the presentation. However, we want to make this as interactive as possible. And so as you see things that you have questions about, please type those questions into the chat window during the session. And go ahead and do them as soon as you think of the question, rather than waiting for the end, because we tend to take these questions in order, and you stand a much better chance of getting your question answered if you type it in early. The webinar is being recorded, and you'll each receive a link to download the recording after the webinar within a few days. So with that, let's get started. Let me introduce our guest. Mike Coman is with Real2Desk. Mike, can you please give the audience just a brief overview of your background and a little bit about Real2Desk?
Yes, thank you, Kevin. My name is Mike Coman. I'm a project leader for Real2Desk. I am working with laser scanning technology for the last 9 years, and we had made many projects for many industries, and from here on I'm going to give to Matteo the chance to present himself. I will have more to say afterwards.
All right, thanks Mike. Matteo.
Thanks Mike and Kevin. I'm Matteo Scanzaroli. I'm co-founder of Gexcel and director for R&D. I'm following mainly developing of our software solution from, let's say, 8 years up to now, and I will pleased to show you better what we have created for better aligning your point later on.
All right, thank you, Matteo. And my name's Kevin Williams. I'm the Chief Scientist at ClearEdge 3D, and just have spent a lot of time in the point cloud industry and really enjoy this industry. There's some really cool technology, and it just seems to be accelerating the pace of development every single day. So it's a fun field to be in, as most of you already know. So with that, let's get started. And Mike, I am going to give you control of the screen. Give me just a second. There you go. Take it away, Mike.
Yes, 2 seconds. Let me see. Okay. Are you guys receiving my screen?
Yes, you look great.
Okay. So I am Mike Coman, as I said before. I am project leader, a Belgian company located in Antwerp, Real2Desk. We as well have a sister company in China, Globe Shanghai, in which we are doing services. We provide services for laser scanning and 3D modeling and BIM solutions. We recently acquired GRC LineUp Pro plus ClearEdge, and we took that as an experimental study because it sounds very fancy, the technology, but it proved itself to be quite reliable and versatile. We are doing projects in all industry, petrochemicals, chemicals, architectural, shipbuilding, etc. We are doing dimensional control, we are doing as-is documentation, etc. So actually what we do, we gather data on site and then we process that data to a specific format or a multitude of formats based on the client request. That might result in 3D models, in 2D layout plans, etc. The advantage of 3D scanning technology, I think most of us know nowadays what it is and how it works. But for the ones that don't know, I could say that it's a very fast way to gather information, spatial information. It's if we place it simple, it's like using a panoramic camera for getting dimensions around, and that's done with a laser, which takes millions of points per second. That's why we have the point clouds from where we get the data and we generate intelligent results out of. So for our first case study, I'm going to present this underground parking garage, which is a very small project of one day. There were 26 scan positions taken per total, and it took us around 2 days to process the point clouds. That includes panorama images generation and colorizing the point clouds. So that includes, let's say, all the necessary steps until we arrive to a final concrete result that we could export and use further on into ClearEdge. Here it's a, let's say, isometric view from the top. The roof is missing. I mean, I took it away on purpose to show the structure inside, and below you see a panel image of the environment, how it was unfolded panel image, yeah, so of the area that was scanned. The advantage of GRC, because we have used GRC for registering the scans, is that it gives you freedom, on-site freedom to decide what scan data you're going to gather and how you're going to do that. As you might well know from previous years, and even nowadays, targets are extensively used. That they are tilt and turn targets, paper targets, flat targets, what type of target might exist. We try to get out of that pattern because we observe that targets are cumbersome to carry on site. If you consider that one of our tilt and turn targets has 2.5 kilograms, and let's say for this project alone we would need like 20 targets, you already can imagine that in 2 people you reduce a lot of extra weight, a lot of baggage to carry around. Renouncing on targets, it's not the only benefit that we get. With the previous workflows, we had as a necessity to have with us a surveyor that at all times for each scan position would measure at least 3 targets. These targets would be seen as well by the scanner and by the total station. Because the scanner itself, it's a dumb instrument, but very focused on gathering massive amounts of data all around, the total station gives it the knowledge to know where it's positioned into space. So between themselves, the scan positions get that information usually from a total station. But because we renounce the targets, GRC empowers us to use the scan data itself to generate the necessary constraint points in order to register these stations and for them to identify themselves in space. For example, another limitation of the targets, sometimes the point of interest for the scanning job, it's omitted or, let's say, not easy to capture because the targets that we should always be constrained to, they are not in the field of view. That means that instead of placing your scanner half a meter in order to catch a good view on the object of interest, you might renounce to that or even have to work around it by generating new scan positions with new targets in order to gather exactly that point. As you can see here in the second image below, the layout scan locations, on the north east side, there are 4 scan positions in a line. They are very close to each other. What happened? We identified on site the fact that we need some extra scan data because there were pipings and elements that we wanted to capture. But in normal ways, we would have probably taken only 1 scan position over there. Because we don't use targets, we had the freedom to take 4 individual scan positions with lower resolution, because not always more means more. In our case, having a better distributed point cloud on the length of an area of interest is better than having 1 scan position from 1 viewpoint gathering that information. That also reflects in the processing time. Having to deal with 4 scans of low resolution against 1 scan of higher resolution, cost-wise will be the same. But in our case, this will bring us at a better result. I will explain this further on. As you can see, after we gathered the scan data, we have generated the architectural part of the building, we generated the structural part, and the piping. All that happened with the help of ClearEdge software. So having a very good scan data will help further on gathering the information out of it properly. These are 2 small views towards areas that have been modeled. I cannot say that it's all perfectly 100% modeled, or let's say not everything was modeled out of the scene, because we only focused on the parts that were interesting to our client. But the majority is there. These screenshots are made in a collaboration software from Autodesk, so that's something more that can be done. For my second case study, and this will be the one that I'm going to discuss the most, because here the true power of GRC and ClearEdge are seen. It's an industrial plant with lots of structural elements, with lots of piping and equipment. For this project, this is a large project, we have taken 107 scan positions. Field work duration was around 4 days. We could have done it easily within 3 days, and let's say we didn't have an improvement on the time on site because we wanted to gather the right data and as well to be safe and to be precise. Before, when we were using targets, we had to do a lot of running around, and as you might know, when you get a project, the first half a day of the project is lost by running after documents, doing the safety training, etc., etc. Working for, running after the work permits, and with the help of our workflow, we can mitigate these downtimes in the fact that once we are on site, we don't need to wait until the surveyor is positioned and he gathered the necessary targets for us. We can directly start scanning, and at any time during this process, the surveyor can measure 4 targets for us for georeferencing. For scan-to-scan registration, we just use the scan data itself. What does this empower us? For example, if you see, we have a pipe rack to the right, which has like 4 levels of pipes, and there was no good accessibility in order to capture properly from the sides or from above, from other parts, but below and a little bit to the right side on a platform to capture this pipe rack. But that was enough for us to take as necessary amounts of scan positions, sometimes even half a meter away from each other, in order to capture the points of interest and capture them accurately, in order that the little bits and pieces of, for example, a pipe that we capture will be able to be identified precisely and accurately. For the workflow, after registering the point cloud, we have used 5 people for 10 days approx. But that was not all at once. It was back and forth, depending, because we are running multiple projects at once. But overall, we had that amount of time. If we would have processed that with our previous softwares, it would have taken us easily double that. And I can say that EdgeWise, now I'm jumping a little bit from the scan processing software to the modeling software, which is EdgeWise. We have used EdgeWise to identify all the structure, all the steel structure, and those are like 5,000 something elements, and that was done within 5 days approximately, while the rest was part identified by EdgeWise and part because it was a new process for us. We did it with our previous software, but we have a very good sense that that's where we are losing a lot of time for the moment. So per total, we had around 15,000 elements for this project, and the clients always want to deliver, wants us to deliver one day before they even release the purchase order. So you can imagine that the time is of essence, and the faster we can deliver data to client or finalize data to client, even if it's partial, the better it is, because the client in their turn can come to a better, let's say, a dynamic workflow of the project. In case they see that they need some extra areas or extra modeling, etc., we can accommodate that based on this collaboration. One thing that I can say, ClearEdge, it's a very powerful software that benefits from accurate data, and any modeling software coming to that point is benefiting from clear and accurate data. But ClearEdge will process the data much faster by having the point clouds registered with GRC. Because what GRC does, it uses up to no physical targets, I say, because we just need targets in order to georeference the scan data on the coordinates given by the client, or Only in special cases we might need targets in order to register point clouds that don't have actual overlap. Another powerful technology that is implemented in GRC software, and we could see it firsthand, it's the competent noise reduction. It's not taking away points that are necessary and just look to be noisy. It's actually taking away points that are really noisy and makes the data more accurate and much cleaner, as I said before. There is the possibility to do a fully automatic point cloud registration, but that's with a small asterisk because, of course, there are cons and pros about that fact. It's a very fast software. For example, I will come here if one scan position will not be properly registered with the rest of the bunch, you can easily, with the tools inside the software, identify common points and then make a new bundle adjustment. But the second time you do a bundle adjustment, because the point clouds are already oriented, is going to take very few iterations. So let's say if for that project that I showed you before, 107 scan position, we have managed to register it successfully within 2 days. And that's a very good time if you consider this against any software that does it by identifying targets. And that's more like, I think if we would have had to make this project with targets, would have taken one person from our team at least 3 days to identify in the point clouds the targets, and then we would have taken again like 2 days in order to arrive to the point that we can actually export our ready to use point clouds. Another thing that we observe with cloud-to-cloud registration in GRC is the fact that when this cloud-to-cloud technology, which as I understood, it's not just a simple cloud-to-cloud, Matteo might explain you a little bit more about how it goes exactly. As I understood, might be something to do with edge detection, etc. I don't know, proprietary way of handling it, but it's a very intelligent way of handling it because when you see the point clouds, they are not next to each other. Like for example, before, in order to deem a result of a registration acceptable, we would have had targets like 5 mm deviation. That would have been the maximum accepted deviation. But sometimes if you looked at 2 point clouds, you could have seen that they are very little, almost unobservable, offsetted from each other. Now when we look at the scan data, we see interference patterns as the point clouds are merged within each other, which is an excellent result. Another strong feature that might seem very simple and insignificant for the GRC software or for any software, it's the batch export. I mean, just imagine having to export after you finalized all that registration, 107 scan positions, and having to do that manually, one by one. Nowadays, software, yeah, it becomes more oriented towards batch export, but GRC just excels at it because at the end of the day, when you have finalized everything, you can just say batch export, and you come next day and you find all your data ready to go to the next step. What disadvantages we have with GRC, if I might call them that, because that's mostly based on the workflow? You need to have at least 30% overlap between scans in order for the process to be able to identify common points and common edges to further register the data. And it's not a magical solution for all field situations, even if it might seem so. For example, for a very tiny project, you can just throw away inside GRC the data, you just throw it in, and then GRC is going to handle it within minutes and you're ready to export and move forward, which is a done deal. It's perfect. But of course, there are situations in which you don't have enough overlap and then you need to take a little bit more different approaches. And for that, I am going to go forward. And here we have the typical situation that we identify on site. The ideal situation in the left corner, top corner, it's when scans have overlap, identified here in the small schematic with lines between the scan positions, which are the round circles. And they, like, let's say, like through magic, they find themselves automatically where they are located and they give a good result. Of course, you might still use targets in order to georeference. That's what the small green triangles are in this situation. As you can see, I just placed 4. 3 are enough, but 4, let's say, it's a minimum just to be certain that everything is going okay. The second approach will be a practical one in which the scans are in a closed loop. So let's say only the lines have the overlapping part. Yeah. So as you can see, one scan has only a view with 2 adjacent scan positions. And at the end, just to make certain that you don't suffer from any drift, you are going to close this loop. So whenever during the workflow you can make a loop, it's advisable to do that. And as well the targets for the georeferencing. The fourth possible situation is when you don't have a loop and you have just a traverse of scans in which you start from a known scan position and you end up to a scan position, another known scan position, yeah, constrained to targets, and all the rest in between are going to find their position and constrain themselves into the system. And the fourth situation, which will present no direct advantage, but it can still be processed in GRC, is the way in which the scans are divided by a wall or whatever barrier, and they don't have any overlap. Or for example, if you scan on a street and a big truck comes into the middle of the street and is just going to take your field of view from one scan position to another, then you might still result to targets in order to do your registration. Another thing to keep in mind, it's like objects, large objects in your scan data that might move. So for example, in one situation we had a crane that was stationary for half an hour in one position and half an hour in another position, but it was taking a lot of view in our scan data. In order to resolve that, we had to take away the crane because the crane itself was acting as registration for our scan positions, and it was generating us error. So what we did, we took it away completely, we registered the scans together, we let the process identify common points and deal with the entire mess what the registration is, and then we bring back the crane, and of course it looked rotated because it was taken at different times in different positions, but the crane was still there, and all the data adjacent to the crane that initially we lost by removing this obstacle was back, and we were able to take advantage of that. This concludes my my presentation, and if Kevin would like to take over, I will be more than happy to oblige.
All right, thank you, Mike. That was a great presentation. Thank you very much. Give me just a second and I will transfer the screen control to you, Mateo. And we're going to we're going to hold off on questions till the end. So again, if any of you have questions on what Mike just talked about, please go ahead and type them in now into the question box. And Matteo, if I can make my GoToMeeting work here. There we go. Matteo, I'm seeing your screen. Go ahead and take it away.
Okay, thanks Kevin, and also thanks Mike for your presentation. So what I want to concentrate my presentation on is, let's say, give you a more detailed description of how the Gexcel 3D Reconstructor works, especially in this LineUp tool. The first key point that I want to emphasize is that, let's say, Gexcel Reconstructor has the capability to handle the raw data format from many tripod scan or handheld scan, and of course we are also able to import and handle, let's say, standard format like E57, PDS, or PDX file. I want to concentrate my presentation especially on LineUp. That was the focus also of the previous described workflow. And to do that, I will show you and describe you a video that shows how the LineUp Pro tool works. To do that, I've used 19 Faro scans, around 40 million of points, and I use LineUp Pro to do the alignment. So let's start video. So as you have also seen before, one of the main problems of each scanning job is to guarantee a good alignment. And let's say if you have a good overlap, like 30–40% in the scan, what you can directly do in LineUp Pro is to bring your data, your raw data, directly in the software. A wizard guides you to select the proper parameter, and the automatic pre-registration starts. During this pre-registration, common features are taken into consideration, and after this step, the user has the possibility to verify if the quality of his pre-registration is good enough. And the software offers you the possibility to compare the different cloud-to-cloud overlapping. You can visualize in map view and slice view. It's enough that you have a rough registration at this stage. It's not the final registration, like in these cases, around 20 centimeters. Then a best automatic alignment run that is not, as Mike told you, just a cloud-to-cloud registration, but there's also a global optimization within the different scan edges. So the ICPs between the different point clouds are run, but then there's also a final global optimization that, especially if you have good loops, it's improved a lot your final result. At the end of your process, as also Mike explained, you have a very useful reports that also help you to understand if something is wrong. So the result, it was 40 million of 0.19 scan, and on my PC, that is let's say a standard PC, a Dell Precision, it takes 7 minutes to do this job. Of course, at the end, you can also verify for each cloud if the overlap is good or not. The other good point is that at the end of this process, and I think Kevin will tell you something more later on, you don't need to export the data in a let's say exchange format, but you can directly enter with the raw file of Reconstructor in ClearEdge. And this of course saves a lot of time, because you can immediately transfer the entire project scan-based project into ClearEdge, and you can start the standard procedure of ClearEdge application. As Mike said before, of course, there could be situations in which the automatic alignment could fail due to not enough overlap or moving object in the scene while you're scanning. The software offers anyhow the possibility to understand which are the wrong, let's say, the scans that cause the wrong registration, and you have tools to manually improve or solve your problem. The software also includes flat target detection, so you could also insert targets in difficult situations, or let's say in any case use target for the funnel georeferencing. So in LineUp we have tried, let's say, to group all the alignment steps that typically in a laser scanner job are needed. After this alignment part, you can directly enter into ClearEdge, and as you probably already know, you can then process your data for your plant and bin application. I just want to say a few words on the other, let's say, tool or other application field in which the GRC Reconstructor can be used. So for bin and plant, you definitely have to jump inside the ClearEdge software. But let's say we have also tool for constructions application, like comparison between as-built model and your original point cloud to create this kind of inspections reports. We have tool for mining, so it's also possible to create digital terrain model and out of them calculate isolane or volume or cut fill volumes. And we have also tool, let's say, heritage or architectonical application with the capability to map high-resolution images, including spherical images, on top of meshing of meshes that we can extract out of our point cloud. So I think I tried to give you an overview of how the registration parts, LineUp Pro parts works, and also on the other possible workflow. Of course, you're free then to ask more questions later on or test the software after this webinar. So Kevin, if you want, I can leave to you the talk and you can conclude the webinar.
All right. Thank you, Matteo. That was terrific. And we're definitely starting to get a good number of questions coming in. So here, right before we go to the Q&A session, let me just talk just for a minute about some of the things that we've been working on the EdgeWise side, just to give you guys an update and talk about what's going to be coming in the not too distant future. So some of the more recent things that have gone into the latest service patch have been an improved COE export. We took care of some issues we had with occasionally we would get disconnects between elbows and pipes and things like that, and that's been cleaned up, and we should get really nice clean COE pipe models out now. We've improved our support for metric piping standards. This is particularly important for guys in the European and really the rest of the world outside of the United States. Unfortunately, we're still stuck using the imperial system. But for the rest of the world who uses the metric system, we've dramatically improved our support for DIN, and particularly in the plant 3D setting. We've rebuilt the package to support Revit 2017, which of course is a biggie. And We've also included support for Innovex, which is fantastic. They've got some really great plant management tools, and we've been working fairly closely with for a year or two now with the guys over at Innovex, and the two packages are extremely complementary now. And it's now possible to bring in an EdgeWise model that was of your piping and steel and whatnot that was built fairly automatically and bring that into Innovex with all of the intelligence behind that. We now, a biggie for us is direct compatibility, of course, with LineUp Pro that you've just seen. So we support the RGP file format directly from LineUp Pro now, which is terrific. That makes that whole workflow a lot simpler. We also have significantly improved our E57 support. If you have used that in the past, it was really clunky. It was a very slow conversion process from there to PTX, which we would then read the PTX files. We now read them directly, which is terrific. And for our ZNF friends out there using ZNF scanners, and laser control to do the registration, we directly support the project files now, which is terrific. Makes it a lot easier to use that. And the dot product scans as well. We directly read the dot product files without doing any conversion in the background, and so that's been sped up a lot. So we've done a lot of file format and compatibility work recently, which is a big part of the process towards getting your end product. What we are currently working on is, and we'll hopefully see in a not too distant release, is a segmented point cloud. We think that this is going to be a bit of a game changer for working with projects, particularly in Revit and in the Autodesk projects or products. Because it's a little difficult to work with a full point cloud inside of Revit, what we're doing is segmenting that point cloud out so that we have relevant points and strip away some of the irrelevant points. And we're building out a set of tools to do that. And that'll probably we'll have a first cut at that in the not too distant future. We are improving our support for PCF to include mixed metric support and making that hopefully a whole lot better compatibility with some of the PCF supported products like CADWorks, SmartPlant. We're also in the middle of working on a steel exporter for PDMS. I know there are a fair number of people who have been asking us for steel support for the PDMS product. And so hopefully that will be coming out fairly shortly. And then language packs. We've made some good progress there. We've been and I apologize, we've been a little bit slow in getting those language packs out, but we are finally making some real progress on that, and we should have probably German will be the very first language pack out, and then we'll have some other language packs to support our customers around the world. And then a biggie that we've been working on, of course, is if you haven't heard about it, is a new product called Verity, which has an engine for comparing design models against a point cloud. And some of the technology that we're building there is eventually going to work its way back into the EdgeWise suite, which will open up a whole number of new workflows. But that's still very much under construction, but just know that we're working hard on that, and it's going to translate into some real game-changing workflow paradigm shifts in the whole modeling workflow for EdgeWise, but probably in the 2017 time frame. So that's what we're working on. And now let's go to our presenters and ask some of the questions. And I do see a good number of questions have been coming in. So let me start this off and ask Mike. Very first question is for you. What was the working time on site? You said well, you spent several days there. Was a 10-hour proper scan time per day, or how much time was actually spent on site doing the scanning?
No, it was more like, let's say, 8-hour scanning day. We most of the time finish around 4 o'clock, and from the previous workflow to the current workflow, before, let's say, we would have finished around 6 o'clock in the evening, and we would have done 24 scan positions with relocation of equipment and all that. And now we have like 30 scan positions within 8 hours or less. So that's a big advantage. Why is that? Because that means that the people can, I'm not saying now that because we can do more, we should do much more. It's not really working like that on site, because one of the most important aspects when you're on site, you need to do your job fast, good, and safe. And safe is not the last part, it's the first part that always comes. So as long as you don't care about the targets, running and turning them around, climbing a stair 10 times, turn it now towards the total station, turning now towards the scanner, it's a big improvement in the comfort of the people on site and in their safety. Okay,
excellent, excellent. This next question is actually, I feel qualified to answer this one. This is, will future EdgeWise versions directly open JRC projects and or scans or complete JRC EdgeWise integration? So the answer there is yes, we do. We read the RGP files directly, so we're fully compatible with a LineUp Pro to EdgeWise workflow, and that's released in this latest version of EdgeWise. Next question is to you, Matteo. Is JRC, and let me try to interpret this as I go. So are you looking at the distances in the point cloud and weighting them differently? So the distances from the scanner location. And is JRC excluding points that are a lot further away from the scanner? So are you, I guess the question is, are you weighting the registration based on the distance away from the scanner of the points? Did that make sense?
Yes, we are taking into consideration, let's say, the range of the scanner to use the let's say the good points, but let's say it's a parameter that the user can also set up because there are situations in which, let's say, the good feature are very far from the scanning position, and of course you don't have too much overlaps. So we are considering this parameter, but it's, let's say, something that also the user can set up.
Okay, okay, perfect. Let me ask both of you this question. Mike, I want to ask you first. Is there a maximum number of scans in LineUp Pro before registration fails or does not produce accurate results? Have you stress tested the software?
Yes, we stress the software with hundreds of point clouds. No, it's just a matter of waiting time. Of course, now probably depends from computer to computer, but as I observed, the software is loading point clouds as he needs them and then unloads them. So the number could be limitless, I would say. I don't know exactly, probably Matteo knows exactly what is the maximum number. We never reached that, and we had, I think, maximum 400 something point clouds.
Yeah, Matteo, what I assume you know the technical answer to this. How many do you have a limit?
Okay, let's say we have did stress tests with more or less the same number of scans that you mentioned. Internally, the software works in an intelligent way, so loading and downloading the point cloud. So let's say depending on your PC, you can be faster or less. So potentially there's no limitation in the number of point clouds. Moreover, I can add something more that I was not able to show directly during the my presentation, but it's also possible before doing the alignment part to intelligently simplify your point cloud and use for the alignment only the principal point cloud edges. And this improves a lot the number, let's say that the time of your registration, and in many cases also the final accuracy, because you are using really the important edges points that you need to align point cloud. So this also improves the final alignment quality and the fastness of the system.
Okay. Here's a question, because there are a number of other cloud-to-cloud software registration packages out there, and what sets LineUp Pro apart from some of the other packages out there in your opinions? I'll let either of you answer this one.
Who start? Well, I can start from my side, okay. I can tell you that from the technical point of view, let's say we stressed a lot our automatic alignment part, that is one component, so the fact that you pre-align automatically without target. And it seems it works very, very well in comparison to other, let's say, automatic pre-registration software. The other key point of our registration tool is the bundle adjustment that we have after the pre-registration. That's, let's say, doesn't take into account only, let's say, the consequent scan sequences or the consequence edges, but it makes a global adjustment for all the scan, and this also improves a lot the final registration, and I can tell you that it's the state of the art of the technology in this application field.
Okay, okay. And does the software accept Leica scan data?
At the moment in PTX format, or E57 if you export E57.
Okay, okay. And let's see, some of these questions are duplicates. If you find misalignment after fine registration, how do you tighten up the point cloud?
Typically, you go through your PDF report and you can see which is the, let's say, the scan that doesn't fit properly, and you can either rerun the bundle with more constraint, or you can see if, let's say, if needs, for example, to edit this point cloud before, let's say, restart the bundle alignment. So typically you can understand where the problem comes from and find out the way to let's say improve the quality. That's the typical way of working.
Okay. And then one more question for you, Matteo, here. Is there a trial version of LineUp Pro?
Yes, let's say for the entire packages, for all the packages of Gexcel Reconstructor, we give out a 30-day trials with the only limitation of exporting result. But in any case, it allows you to test then EdgeWise, because there's no export, as you explained you before, so you can test the alignment and then the workflow in your EdgeWise package. So there's a 30-day trial at the moment.
Okay, excellent. I know a lot of people will appreciate that. And let me ask both of you guys, is it okay to provide a PDF of the presentations that you gave? So we've got Pedro Valadares asking for a PDF. He didn't say which one, but I imagine they're both valuable. Would that be possible?
No, from my side, there's no problem. I can send you the PDF and also the video.
Yeah, there is no problem from my side. I think you already have the PDF from my side, so we can just forward it. One thing I would like to add about the GRC software, and that will be like if you work with large amounts of point clouds, you have the option to group them. For example, let's say one room, it's not connected to the rest of the scan data, and you only have a hallway that connects those scans to another bundle of scans, let's say. It doesn't help to throw all of them in the automatic bundle adjustment at the end, because you can make a group in which one of the scans will act for all of them. So that way you minimize the processing time, and also you maintain your accuracy of that specific group in relation to the rest.
Perfect. We're running out of time, so I'm only going to ask a couple more questions here. Next question is EdgeWise 502 available? Yes, it is. We'll be sending out a global announcement in the not too distant future. If you need it earlier than that, just send a request to our service@clearedge3d.com, and we can get you the latest version of the software. PDMS Steel, Pedro Valadares was asking about this again. It will be native PDMS language, just like piping, so it'll be intelligent steel. That's the goal of this new steel export. This is another one for me. Are you planning for the segment and point cloud to separate MEP versus architectural? Yes, that's the idea, is to segment out specific portions of the point cloud so that you don't have to fight with the whole thing. If you're only focusing on MEP, export out the MEP section of that point cloud. I think that'll make it a whole lot easier to do follow-on detailed modeling inside of Revit, which should make Revit a whole lot easier to use. And just to kind of clarify the workflow between the EdgeWise and the JRC software, they are two separate standalone applications, but they communicate very well via file format. Any possibility for processing mobile scan data? What kind of point cloud format can be imported into JRC? Matteo?
Yeah, you can handle, let's say, any point cloud. You can also import LAS file or E57 file. And let's say for us, it's not a problem also to automatically align, let's say, not tribal scan or group of scans that you have already mixed in a single point cloud. We have also used it to, let's say, align mobile scan or, for example, UAV data with terrestrial laser scanner or a handheld scanner with a tripod scanner, so that the alignment tool is very flexible to handle different data sources from different sensors. That is possible.
Okay. Fantastic, very cool. Well, we are several minutes over, so I'm going to call it at that. I appreciate everyone for attending. Hopefully this has been a very informative session. Like I say, we've gotten a lot out of the LineUp Pro technology, and thought it would be a very worthwhile session to have. Hope you guys have benefited from it, and we'll see you next time on the next session of Workflow 4.0. Thanks for attending, everybody.